What's happening with this mug? If it gets close to the speed of light, it becomes heavier than the whole universe. Why? Well, to accelerate the mug, we use energy, and that energy goes into the mug, and energy is mass, as Einstein tells us. When the mug's speed increases, its mass becomes greater, and as it gets heavier, the mug becomes even harder to accelerate. Even more energy is consumed, which increases the mass even further, and that's how a chain reaction is created. However, if the mug nears light speed, it would weigh as much as the universe. Who could provide enough energy to accelerate it? The mug's speed will not exceed the speed of light. What's with this Schrödinger's cat, sir? Well, it's one that would be both alive and dead at the same time. How does that work? Well, look, all subatomic particles have this property called quantum superposition. They can be in several places in space at the same time. And a cat is made of particles. Schrödinger then came up with the following thought experiment. Each particle in the cat would be placed simultaneously in two positions, a bit to the left and a bit to the right. On the left, the particles will form a living cat, and on the right, a dead cat. Attention, each particle is simultaneously both on the left and on the right, so what do we have then? Well, do we have a living cat on the left and a dead cat on the right? The cat exists in both states at once, but don't try this with your cat at home. Even physicists can't do it. Why is outer space dark even though the cosmos is full of bright stars? Well, because space is a vacuum, so why do the stars still shine? Because photons, the particles of light, pass through it like it's nothing without being deflected. Photons travel freely through the vacuum of space. Not even a speck of dust alters their path to our eyes. That's why, paradoxically, even though space is full of photons' light, it appears dark to us. Fortunately, the photons that come directly to us from the direction of the stars reach our eyes, and that's how we see bright stars in a dark space. Did you know our solar system could be visited by a black hole every 10 years? Wait, don't panic, we're not talking about those massive black holes you've seen in the movie Interstellar. They're mini black holes, no bigger than a hydrogen atom, and they could have formed right after Weinberg. That's why they're called primordial black holes. Even though they're so small, they would have the mass of an asteroid. Well, don't expect that when they enter the solar system, they'll disturb the motion of the known rocky planets, especially that of the dwarf planets. Astronomers are watching for unusual orbital movements not only in dwarf planets but also in Mercury, Venus, Mars, and Earth. If it happens to hit Earth, don't worry. It would pass through Earth like a miniature arrow. As it moved through Earth's matter, it would interact very little with the surrounding particles, eventually leaving behind a trace of gravitational disturbances. So far, nothing has been observed, but hey, be ready for such news, so subscribe to this channel. How can you travel? What if you go back in time? Look, let's say I tell you the secret now. What would you do? You'd go back in time and decide to live your life differently. You decide to stop wasting time on social media so you won't see this video anymore, where I would be what? Then explain the secret to yourself. How did you get back in time if you didn't even start the journey? This is the grandfather paradox, in a version where, by traveling back in time, you prevent your grandfather from meeting your grandmother. So that one of your parents won't be born, and therefore you wouldn't have been born either. Who then went back in time? The paradox is resolved by space-time loops, which relativity theory permits under certain conditions. They say you can go back in time, but then you'll do exactly what you did in your first life. At the end of your second life, you'll go back in time and live the same life a third time. And so on in an endless cycle, kind of like a modern CC, or if you want, the movie Groundhog Day. Have you seen it? What you see here is complete nothingness. It's literally an empty space. Why do we see something in it? Because our world is described by quantum mechanics, which behaves very strangely at the microscopic scale. What we see in this simulation of empty space are quantum fields, which are present everywhere in space, even where there is nothing. From a classical point of view, why? Because they also follow the uncertainty principle, which says you can't know both a car's speed and position at the microscopic level at the same time. If you find out its speed, the car could be anywhere, and if you find out its position, the car could have almost any speed. A quantum police officer couldn't find drivers because he can't write both the speed and the location where it was exceeded on the ticket. The uncertainty principle says that all quantum fields can't stay still forever. Quantum fluctuations appear in them for short periods of time. That's what nothingness looks like, according to physics. Subscribe so you don't miss anything. Don't be scared. If our sun suddenly turns into a black hole, it won't look like this, or like this, or like this, none of these dramatic things. Because then the sun turned into a black hole would have a diameter of only 6 kilometers. From Earth, a black hole at the solar system's center would be so tiny you couldn't see it in the sky. It won't consume Earth or the other planets. In fact, since the mass of the sun remains unchanged, the gravitational pull on each planet would stay exactly the same. That means all the planets would continue their orbital motion as if nothing had happened. The only thing that would bother you is the lack of sunlight. For that, however, you would have to wait 8 minutes and 20 seconds from the sudden transformation of the sun, because that's how long it takes for the light to reach us from there. If you spend the first dark days watching movies and eating by bulb light, things will get much worse after that. Without the sun's energy, the oceans will freeze and the temperature will drop so low that even the nitrogen and oxygen in the atmosphere could condense and freeze on the surface of the Earth. Without solar radiation, photosynthesis stops, plants die, and animals face food shortages and harsh conditions. Until next time, I'm Christian Presura. Stay cool and all the best. Goodbye.